Aloha and welcome to this module on continuous integration. Continuous integration is an extremely simple idea and extremely powerful. It's going to revolutionize the way you do development, and in particular, it's going to make developing in groups way simpler and more efficient than it was before. Once you start using continuous integration, I claim, you'll never want to not do continuous integration when you do development. It's just that good and fun, actually. So let's see what it is. Fortunately, it's not complicated at all, given what you've already accomplished in this class. And now you're going to start to see the benefits of the investments that you've made in learning Ant and acquiring our build system that enables you to do automated builds, automated tests, and so forth. This is the payback. Continuous integration, super easy for you to do now that you've done all that initial development work. So, the objectives of this module, we want you to understand why continuous integration is such a rockin' thing and how you can integrate it into your current build development process, which is simple, and how to use a continuous integration tool called, well, unfortunately, it has two names. It's called both Hudson and Jenkins. The reason being that, I don't know, maybe 5-6 years ago, a guy at Sun Microsystems started building a Java-based continuous integration tool called Hudson. And he did a really good job. Very simple, extremely simple to use, very extensible. He had a large user community. By the way, it wasn't only useful for building Java projects. It could build anything at all, really. It just happened to be implemented in Java as its underlying language, but that's basically irrelevant for our purposes. It could have been anything. But he happened to do it in Java, and he happened to be at Sun Microsystems, and it was an open source project at Sun Microsystems, all those things being good things. Then Oracle acquired Sun Microsystems, and in the process acquired that project. And there were some skirmishes, and essentially what happens, there was a fork in the project. So now the Hudson project continues, but then the lead developer from Hudson and most of the primary committers left to form this new project called Jenkins. And so kind of out of loyalty, I'm using Jenkins, but they're almost identical. The divergence, it was really, I think it was kind of like a licensing issue. I'm not quite sure why exactly it was that they forked. It was quite unfortunate, really, for the community. Anyway, you can pick Hudson, you can pick Jenkins. They both, I don't know whether there's any significant difference in functionality between the two, because the code bases are very similar right now, and you'll often, when people talk about, they'll often talk about Hudson/Jenkins, because really either of them are fine. Anyway, we're going to use Jenkins in this class. So why would we want to use a continuous integration process in general and a technology like Hudson or Jenkins, which implements it in particular? There's other technologies out there, cruise control, which is one, but Hudson/Jenkins is really, I think, the easiest one to use at this point in time. The main idea is that when you have a bunch of people working on a project, you've got the integration problem. Okay, how do you merge together the changes that people have been making to the system in parallel, okay, in such a way as to make development move along as fast as possible? And there's several ways you can kind of fail to integrate correctly. One way to fail to, or one potential cause of failure is when two people modify the same file. And even maybe the same line. That's certainly going to be a problem when you try to integrate. Another problem could be that people don't even modify the same file, but they modify different files, but they modify these files in such a way that the system no longer compiles. So for example, you're writing some code, you depend upon a class, method foo in another class, and then the person working on that other class renames or even deletes that method foo, all of a sudden, your code is broken because they've made a change to the class that you depend upon. A third level is test conflicts, and that's when everything compiles and everything kind of runs, but there's been concurrent changes to the system such that the tests don't pass. So maybe you were relying on a method which did some kind of computation, returned some value, and then someone unwittingly made a change to that class. Maybe they tried to make it more optimal, work, run more quickly, and in so doing changed its semantics so that it didn't return exactly the same value as before, thus leading to a test failure when you try to run the test on your code, which depends upon their code. Their code now works differently. Your code no longer works through no fault of your own. Okay? So you're going to run into probably all of these different kinds of problems when working together with others. It's a real pain. Okay? So what do we do about that? The problem is that when you have these kinds of errors, figuring out what the problem is and how to correct it can be a problem, and it's a bigger problem if the time between the moment at which the mismatch, the inconsistency in the system occurred, and the time when it's actually discovered is long. Okay, so the more time that elapses between the time that you introduce an inconsistency and the time that you detect it means even more things can be done that were based upon that initial inconsistency, and you got to unwind a lot more work. Does that make sense? So ideally, ideally we'd like to be able to detect these inconsistencies as immediately as possible, as quickly as possible, because then we haven't done a lot of further work that depended upon those initial problems, and so we can rationalize the system, make it consistent, take care of the compile problems or the testing problems or so forth close in time to when we actually made the mistake, and then the system can continue on, and we don't have many months down the road trying to put pieces together that don't actually fit. Okay? So continuous integration arose out of that notion that, whoa, it would be really great if we could take care of those inconsistencies that will inevitably arise when people are working concurrently as fast as possible. And there were some preconditions that had to be satisfied in order for this to work. First thing is, we have to be able to build and test a system automatically, okay, because we want this to be all done automatically. The system must be under configuration management control, and crucially, people need to be committing changes frequently. So the whole thing falls apart if you work on some part of your system but don't commit it to the repository, except every month or so. So you've got to be able to actually divide up your work into small pieces such that you can finish kind of a logical chunk, the system all works, and you can commit that change to the repository. Okay? Now if all of these things are satisfied, then what you can do is you can have another tool that sits out there that's monitoring the configuration management repository to see when anybody commits anything. And every time somebody commits something, this tool could automatically check out the new version of the system, run your build scripts, run your tests, make sure everything is okay, and if everything's not okay, email the developers to say there was a problem. Okay? And so what this does is this leads to this idea, continuous integration, as the name suggests, which is that people are working concurrently, doing development, but doing development in very tiny increments of only a day or two of work, at which point they check in their changes to the repository, and we have a tool which now automatically makes sure that the resulting committed version of the system is going to pass all its tests and compile and so forth. Okay? So it's really awesome. The nice thing about it is that you know when the system is in an inconsistent state, and as long as people are committing regularly, you know it quickly. Furthermore, because people are committing more frequently, because they get this benefit of continuous integration, that means that the system is more, it's deployable. It moves along in smaller increments that are always, kind of usable at that point in time, which leads to just a nicer kind of development flow. Now, what's great about where you guys are is that you now know how to build your system automatically. You now know how to test your system automatically. You now know how to put your systems under configuration management. You hopefully will commit changes frequently. So the only thing left is to have the automated tool that monitors Google project hosting for changes, checks out the stuff, and does it. And that's what we're going to show you right now. Okay? Here's what the homepage for Jenkins looks like. Just it's not a big deal. You can see that it runs in a lot of different environments, blah, 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 blah. Okay, so Jenkins runs as a server. I've set one up, so you don't have to worry about that. There's the URL right there. And what you do is you log into this server. Now I'm going to have to give you the password in class. So you guys have to show up to class to get the server so you can actually do this assignment or work with Jenkins. But there's the URL for it. And once you can log into Jenkins, then you can define jobs. And a simple job that we'll show in this screencast is one that connects to Google Project Hosting once a minute to see if you've made any changes during the past minute. If so, check out those changes, build the system, run JUnit PMD checks down find bugs, and then if any problems occur, email the resulting problems to all members of the development team. Fantastic, yeah? Okay. So what about, this whole verify thing? Do we still need to do it? And the answer is absolutely yes. Okay, you don't want Jenkins to fail. You don't want Jenkins to be detecting all your errors for you, because then you're sending out emails to everybody and it's a hot mess, as they say on Project Runway. Okay? Instead, you're going to continue to use verify to make sure, as much as you can, that the system is fine, okay, on your local workspace. And then you commit those changes, and hopefully 99% of the time, Jenkins builds it, and Jenkins is basically going to run verify itself, and everything will be good. What Jenkins is great about detecting, okay, is the following situation, which is all too common. You're working on your system, you add a new class, you document it correctly, you have the test cases, everything's great, okay? Verify runs like a dream on your local environment, but you forgot to SVN add that class file, okay? So that when you commit your changes, you're forgetting to commit that new class file that you've just defined. So on the repository side, the system won't even compile anymore, but you don't know it because locally you can run verify just fine. So there's a whole class of errors like that, having to do with the characteristics of your local workspace, and those errors are kind of hard to detect because, after all, verify passes in your local environment. So what's great about Jenkins is that once you do that commit, within 1 minute, Jenkins is going to actually try to run the build. At that point, compile will fail because you forgot to SVN add it. It's going to send out an email. You'll go, oh my God, I forgot to, I just spaced out, forgot to add it. You can fix it. Jenkins passes. Life is good. Okay, and hopefully that will all occur within this brief interval of time before any other developer is basically even, aware or trying to do anything. Without Jenkins, what would happen is verify build's good for you. You commit, the changes, but forgetting to add that new file. You think everything is great. You go to sleep. The next developer, tries to SVN update at like 1 or 2 o'clock in the morning because, that's just always how it is. And voila, the system's broken for them. Okay, and they're all bummed out. They do a SVN blame. They find out that you were the last person that committed. They think you didn't pass, you didn't run verify, blah, blah, blah. Then the next morning, You wake up, you see this nasty email from them, you write them a nasty email back saying, no, I did run verify, it must be some problem with you, blah, blah, blah. Whole shooting match ensues, blood is shed, you don't speak to each other again, who knows, all this stuff could happen. And it could be all avoided by having Jenkins be able to tell you right away, dude, you forgot to add a file. It's no longer compiling. Once you see that kind of error message, you're going to immediately realize, that's crazy, it compiles for me. And then the next thing you'll realize is, oh, I forgot to add that file. So the tranquility of your development team is enhanced by having continuous integration. Okay. The other thing that's great is also Jenkins and continuous integration in general serves as like a sanity check. Okay, so if it runs, let's say that the system runs good in your environment but doesn't run good in somebody else's, it doesn't pass verify in their environment, you're like, what's the problem here? Who's got the problem? Well, if the Jenkins build is successful, then you basically know it's some problem with that other person's environment. And if the Jenkins build is unsuccessful, then there's some kind of thing going on with your environment. So it's kind of this impartial judge of the buildability of your software project. So that's pretty huge too. Okay. So the way I want you guys to go about this is to define a new file, which you will have to SVN add and commit to your Google project, called jenkins.build.xml. And inside this build file, you're going to define whatever it is you want to have happen under continuous integration. The easiest way to get started is to say that what happens under continuous integration is exactly the same as what happens when I run verify. And here's the lines of code that do it very simply. You're going to define this jenkins.build.xml. You'll have the project name Jenkins. The default target will be Jenkins. You define the target called Jenkins. It depends upon the verify target. Okay, you're all done. And it imports the verify.build.xml, so you get all those definitions. Okay, I like you to start this way because it is the simplest way to kind of get a grip on what's going on. What you'll discover as you get more advanced with your continuous integration usage is that you may want to have your continuous integration build process be a little different from your verify. Okay, it may run extra things and so forth, or you may have basically daily targets that run under different kind of jobs. Anyway, there's more complexity that you can introduce to the continuous integration process. I like isolating all that build code inside a special purpose file, jenkins.build.xml. But to get started quickly, we can just make it very simple. So that's the reason why I don't have you just run verify. I like you to set it up so that you can evolve and make your continuous integration stuff more complicated, more sophisticated over time, and you've got the framework set up already for that. Okay, so setting up continuous integration, you got to log into a Jenkins server. I'll give you the password in class for how to do that. You define a continuous integration job for your project, and the easiest way to do it is to simply copy the Watt Depot Simple App job, which I've got set up, and it'll do almost everything that you need it to do. I'll go through that in a second. And then you want to kind of build the system. You want to do a test commit to see that everything's works fine when you commit, when you make a change, run verify. And then also it's important, and make sure that the build is triggered within a minute. And then it's also important to check to see what happens when you make a change that actually breaks the system, that the appropriate things happen. Okay, so let's try that out, shall we? Okay, so the first thing I want to do is just show you that I've added a new file called jenkins.build.xml to my Watt Depot Simple App application. And as I was talking about before, it's simply going to import the verify.build.xml, and it's going to run the verify target. Okay? And in my subversion, you can see that this jenkins.build.xml has been committed, And we can also actually even see it if we go to let's see, let's get to it this way. Here's Watt Depot. Here's Watt Depot Simple App. And then if I go to source and I go to trunk, there she is, jenkins.build.xml. Okay, so this is the first thing that's very important to do, is you got to define this file, and it could actually be just a copy of this. You could just download this file and copy it directly into your directory, because it'll work just fine as is. But you got to have that in your project. Second thing you got to do is go to dasha.ics.hawaii.edu:9859, and that will bring you to the Jenkins continuous integration server for our class. You'll see that I am logged in right now as ICS413, which is the username that I'm using, and I will give you in class a username and password so that you can log in too. If anybody can go to this site on the internet and see the status of these projects, which is reasonable. But without being able to log in, you cannot make any changes or define new jobs. Okay? So let's take a little tour through here. This has one job defined for it, so let's take a look at that job. This is the Watt Depot Simple App job that I defined a couple days ago. And you can see it has a listing of all the different builds that have occurred. It's got some things you can do. You can configure the project, you can delete it, you can build it if you want. And so let's just try to manually invoke a build. Now normally what happens is we don't manually invoke builds. We have the builds invoked for us automatically whenever there are changes made to our underlying configuration management repository. So maybe just for fun, let's do it that way. So let's make a change to jenkins.build.xml. We'll say currently do the same as verify. So I've made this change, and now I'll commit the change, and I'll put a little message, improved Jenkins build file documentation, and I'll commit. We see the little commit thing going. Okay, so now it's committed. So let's go back to this, and I'm going to enable auto refresh, which means that every 10 seconds it's going to update our system, and we can kind of maybe even just go back to the top level. Okay, so every minute it's going to check the repository. So I don't know the next time it's going to actually look or not. So we may have a few seconds here. Up, yeah, that just refreshed the page. So you can see down here every 10 seconds it's going to say that it's looking for things. So far, not so good. It's not making any changes. And while we're waiting, what I can say to you is that you could actually subscribe to this if you wanted to. You can also, it's also quite interesting, you can have multiple concurrent builds. That's what this build executor status is. Okay, so now it's pulled the Google code, my Watt Depot Simple App repository. It's discovered that I'd committed a change, and it did the whole thing. Okay, so let's see what happened. So it just did a build. And we have a green ball, which means the build was successful. So we can click in to get a look at the details of this. So the first thing is we click to here. We can see that the configuration. I'll disable auto refresh because nothing else is happening now. Here's my configuration management message, and I could click these links to find out more details. We can find out, we can even see exactly what line of code I changed. That's pretty nice. but we'll go back to here, and what we'll look at, which is very useful, is the console output. And when you're actually doing a change, it's kind of cool to watch this in real time. Okay, but it'll show you that this was started by a change to our configuration management repository. You can see the update command. Now we see that Jenkins.build.xml was actually changed, and then it is going to run this command, which is it's going to run the Jenkins.build.xml file, which is going to invoke the Jenkins target, which is going to invoke the verify target. And then we see all the stuff that it does as part of doing verify. The build was successful. Jenkins target here, and so everything's good. Okay. And just for grins, if we go back to here and we do a build now, you can manually invoke this, and then if we click here, we can go to console output. Here it says started by user ICS 413, so we know how this was actually invoked. And then you can watch the progress of the build in real time, which is pretty groovy, I think. Okay, and as you might expect, it's going to be successful again. Okay? Okay, now let's, just for fun, let's mess things up. So let's go to simple application, and let's just delete a semicolon so that our project does not even compile, and let's not run verify, okay, which would detect this error. Oh, I got to refresh. Okay, and did I forget to? I must not have saved this. Okay. Here we go. Okay, so test commit with broken system. Don't do this at home. Okay? So anyway, we're going to commit a broken system, and I'm just doing this so you can see what happens when there's a failure. So commit, 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 commit. Okay, it's committed. And now we go back to Jenkins, and we go back to this project, and now we see that it's doing a build, test commit with broken system. Okay, and so we see the builds failed, okay, because it didn't compile. And that means if we go back to the top level, you can see we've got a red ball now. And also, we could see that I'm going to receive an email about the fact that the system failed. And just for fun, let's see if I got that email. Okay, so here's an example. Build failed in Jenkins. Okay, I get a pointer to the job. I get what I, committed, and then I get a copy of the output. Okay, and we can click here to go back, and we see exactly what's happened. Okay, so that's pretty sweet, actually, if you ask me. All right, but we don't like things being that way, so let's reintroduce our semicolon. And let's refresh and commit our fixed version of the system, because it's very stressful to have a broken system in configuration management. I don't like it at all. Okay, and so very shortly we will see that Jenkins is going to rebuild this system. Okay? So let's now go to the configure dialog so that you can see how it is that you set up one of these jobs. Okay, you have to define a project name, and the project name should be unique within this Jenkins server. Oh, you can see now it's about to start doing things. You can have a description for it if you want, And then you can specify the Google Code website, which is, the Google Code website. We specify, I installed a plugin so that it knows about Google Code, so I click on that. And then you can specify how you want this thing to be built. And normally, the normal case is that you want to pull the software configuration management repository. And then there's this schedule, and this is designed to pull it every 1 minute. And it actually would be, you could actually get rid of that /1 if you wanted. But the reason why I specify it this way is that if you wanted it to be every 5 minutes, you just place that by a 5. If you want it to be every 15 minutes, you replace it by a 15. So it just simplifies. You don't have to remember how the crazy star thing works. If you have to, kind of refresh your memory, you can click on that help thing and it'll show you. Okay, you want to invoke ant, and what I did is I added a build step which said to invoke this particular build file whose default target is Jenkins. Okay, so that's the way that we get it to invoke the Jenkins.build.xml file, not just the regular ant build file. And then the final thing, there's a lot of different things you can do. The simplest thing to do is to just email the developer when there's a failure, so that they can know about it and do something about it. And in general, when you work in teams, you'll list all of the team members here so that people can be informed. Okay, so we can see that it's been rebuilt. Now it passes. Everybody's happy again. The last thing I want to cover is how is it that you would add your own project to this Jenkins server. And it turns out it's super simple. Okay, what you do is you go back up to this top screen here and you click the new job button, and let's say we're going to implement Watt, Depot, Katas, Johnson. Okay, something like that. So as a as a convention in this class, or as mandated in this class, the name of your job should be the name of your project. Okay, just like and the name of your project is the same in Eclipse, the name of your project is the same in Ant, the name of your project is the same in Jenkins. Just use that one name everywhere. Use it as the name of the directory on your file system. If you just keep doing that, you will find that as life gets more complicated, there's just lots of less things you worry about because you've got a consistent naming convention for all the different places that you're talking about this project. Okay? I know every semester some of you think, no, I don't want to type that whole darn thing out. I'm going to shorten it. It's going to be way better. But I can tell you that it's not better. It's worse. Okay? It's always better to fully specify the name of your project and use the same project name in Ant, same project name in Eclipse, same project name in Jenkins, same project name in Google Project Hosting. Okay? All right, anyway, sorry for the little sermon, but I just see it all the time when I'm helping you guys. It's like, dude, it's not good. Okay? So specify the job name as being the same as your project. And then you're going to say copy existing job. And you'll copy from Watt Depot Simple App. Okay, which we just saw works pretty good. And then click OK. Now we've got a new project, Watt Depot Katas Johnson. Cool. And what you have to do, basically almost the only thing you have to do, well, there's two things you have to do. One is you have to change this to be the name of your actual Google Code project. Okay? And the other thing you need to do is change the recipients to whoever it is, joe.smith@gmail.com. Okay? And everything else should basically be okay as long as you've defined your Jenkins.build.xml file the same way that we did. Okay? And if we do save, now we've got a new project called Watt Depot Katas Johnson. It's not going to work because there is actually no Google Code project like that. But if we go back up to Jenkins, see, now we're trying to build, and it probably won't work too well. if we click on this, we'll see that, and then we click in the build history, and then we click console output. Okay, it's like almost immediately we get an error because we couldn't check this thing out. Okay, but had we actually had a project, hopefully it would have all gone fine, or if it didn't go fine, then you'll have learned something useful about your project or about configuration management. Okay, so we're going to go to here, and what we'll do is we'll click this, and I'm going to delete this project because, you know, it didn't really ever exist. All right, there you go. Your introduction to continuous integration. It's extremely simple. I don't think you're going to have any problems at all with this. At least I hope not. And I think you'll find the benefits are enormous. So enjoy.